Resilience is the ability to persist over time.
In the Manila Bay and other bays that experience red tides, it is the marginalized that is affected in health and in economy.
Yung engineering is the ability to absorb, thrive, and then recover. The faster you're able to recover, the more resilient.
Sa Pilipino, ito ay katibayan at katatagan sa mahirap na sitwasyon at ang kakayahang bumangon muli.
Yung ecological naman, the ability to adapt. Yung evolutionary resilience, vale, to really innovate and be creative.
Resilience is really being able to spring back from adversity, but it should have learning, and therefore it strengthens you to be more resilient than before the adversity came to you.
Before COVID-19, the Philippines was already on to SMT-based measures to improve its resilience capacity. With COVID, the country was awakened to the need for resilience of our economic, health, and educational status as well.
The country as a whole is, I think, not so resilient because while we have the capabilities, the opportunities, and the resources to cope with COVID-19, the whole body is suffering because the leadership and management is not working so well. When it comes to individual resilience, those who have more resources, capabilities, and opportunities will be more resilient than those who are not.
A lot of the problems really may be interconnected, vale. You have to look at it from a holistic point of view. It encompasses more than natural sciences or physical problem, vale, but also it gets into the ecological, biological, as well as social pa nga.
Among issues and problems we have are poverty, ecosystem destruction, climate change, and variability.
Much of our attention is placed only after the disasters happen. What we should do really is to take early action years before the hazard strikes, and we should put our attention and our resources into that type of planning.
We need SMT-based transdisciplinary and inclusive approach to coping with possible hazards.
The fragmentation of society needs to be resolved for resilience.
Communication is very, very important, and we should communicate to the people using not just scientific communication means, but through arts, music, understand the mindset of the Filipino people so we can communicate better.
Well, the way to move forward is interoperability.
We have to do a lot of work as a person, as a community, and as an institution to really have resilience as one of the values of the Filipinos. Yung tunay na resilience na towards improvement.
Building resilience requires sustainability science inspired by transdisciplinary approach.
To be sustainable, you have to be resilient. To be resilient, you have to be sustainable.
Go natural, go with nature's flow. Non-structural or natural interventions, as well as good planning, is the most sustainable.
Finally, we need to harness and strengthen the Filipino spirit of bayanihan.
Pero dahil kami ay nasa akademiko,
Kailangan
pinag-aaralan
natin
namin
matingnan
yung
kung
mga...
ano talaga ang kailangan natin not only for ourselves, but for a people as a whole.
Resilience ng mga Pilipino towards the collective effort among communities
Not to blame anybody.
and the strengthening of
Resilience Live.
Hello everyone, good afternoon, and welcome to the fourth episode of the Resilience Live webinar. It's me again, your host, Ella, for this afternoon. Again, the Resilience Live webinar series has been brought to you by the UP NOAA Center and the UP Resilience Institute in partnership with the UNESCO International Geoscience Program, or IGCP. Together, the UP NOAA and IGCP seeks to explore geoheritage as a tool in developing resilience towards natural hazards. So for today, we have our partner organization here with us, the UP Phi Delta Alpha Sorority, the UP Society of Geodetic Engineering Majors, or UPGEOP, the Association of Filipino Pharmacy Students UPLB, or ACS-UPLB, and the Lyceum of the Philippines Laguna Biological Society. Thank you, everyone. So our speaker for today is a researcher under the Water Resources and Environmental Research Center in K-Water Research Institute. It is the premier public organization that specializes in water resources management in the Republic of Korea. She holds a bachelor's degree in physics from the Polytechnic University of the Philippines, a master's degree in meteorology from the University of the Philippines, Diliman, and a doctorate degree in hydrology from the Chungnam National University in Korea. She specializes in atmospheric and hydrological interaction, urban flood modeling, climate change projection, and tropical cyclone intensification. She has also presented and published hydrometeorological extreme event case studies here in the Philippines. That includes the Habagat in 2012, Typhoon Ondoy in 2009, Typhoon Yolanda in 2013, and Typhoon Ulysses in 2020. So here to discuss her presentation in tropical cyclones and water-related disasters, we have Dr. Leia Dasales. Hi, Dr. Leia. You can now share your presentation.
Hi, good afternoon, everyone. My name is Leia Dasales. I'm a researcher working for the Korea Water Research Institute located in Daejeon, South Korea. And today, I will be presenting a discussion about tropical cyclones and water-related hazards. To proceed, just providing a brief background, as mentioned earlier, I have done PhD in hydrological engineering in Chungnam National University, and I've also pursued master's in meteorology in University of the Philippines, Diliman. So my research has started since 2013. I have worked as a science research specialist for NOAA Center from 2013 to 2018. And I've also had a privilege to work for APEC Climate Center, which is located in Korea. Also in University of the East Philippines. And right now I'm working for the Korea Water Research Institute in Daejeon. So to provide a brief outline of my presentation, I will be discussing what typhoons are, what are the associated water-related disasters, what is the implication of climate change to this kind of hazards, and also we are going to be discussing why we are vulnerable to these kinds of hazards. And as I believe most of the participants today are students or researchers, what can we do to be able to mitigate the situation? And lastly, I will be providing some open data sources that will be necessary for research regarding these hazards. So to continue, tropical cyclones form because of the low pressure area within the international ITCZ, or intertropical conversion zone. So the Philippines is located within this location. So that is the reason why we receive a lot of tropical cyclones throughout the year. So tropical cyclones form as the beginning of a low pressure area. So as we have from science experiments, so low pressure areas tend to receive a lot of materials or molecules from the high pressure areas. So that's the reason why the tropical cyclones form. So in different locations on the world, we are located here in northwestern Pacific Basin, which we are together with Japan and Eastern Asia. In this location, we call tropical cyclones typhoon. But do you know that in other locations in the world, for example, in North America, we call it hurricanes. For South Asia, in Indian Ocean, they call it cyclones, as well as in Australia. So when people ask you what is the difference between hurricane, tropical cyclones, and cyclones, you can say that they're all the same. They're just from different locations in the world. So as we can see, what are water-related hazards accompanied by tropical cyclones? So the most hazardous we experience is the water-related hazard is the flooding. So we have different kinds of flooding. We have pluvial floods. Pluvial means rain. So anything that is rainfall related that we experience flood is we call pluvial flood. And then we have the fluvial, which means river. So overflowing of water from river is we call river floods. And lastly, we have the coastal flood, which is a storm surge. So storm surge happen when a tropical cyclone is located on the ocean, and the wind and the pressure helps with pushing the seawater into the coastal area. So aside from flooding, we also experience different kinds of hazards, such as the rainfall-induced landslides. So what happened is, if we receive a lot of rainfall in the mountainous area, it tends to flow towards the low elevation area, accompanied by the soil and the debris. So we can experience landslide regarding this. And in addition to that, long-term flood can trigger waterborne diseases such as leptospirosis, cholera, typhoid fever, hepatitis A, which is related to the quality of water being stagnant for a long period of time. So since long time ago, 1960, we have experienced an increasing number of water-related disasters. It's because of the urban population has been growing since that time. And so people living on a most tightly dense community tend to experience more water-related disasters resulting to that. So I guess we have heard about climate change before. Climate change is the variations in climate resulting from the continuous additional of greenhouse gases into the atmosphere. So climate change, the effects of the climate change can vary. For example, we have the rise in global temperature. Because of the rising global temperature, there's going to be a lot of melting of ice from North and South Pole. So this is the reason why there is a potential sea level rise due to this change. In addition to this effect, we according to recent studies, we have also predicted that there's going to be an increase in intensity and frequency of tropical cyclones globally, and also changes in the rainfall pattern and intensity. So as you can see in the figure, the global temperature anomaly since 1880 has increased, meaning that we have been increasing even though a very small change in increase in temperature since the 1800s. So because of this, we are expecting to have a lot of water-related disasters due to the effect of climate change. So what are the risks of climate change? So there is an increase in greenhouse gas, which is in turn results to global warming. The global warming induced increase in sea level or sea surface temperature, the melting of glacier and ice, and thermal expansion of ocean. So with this effect, we are expecting to have an increased rainfall-induced landslide risk. There's also increased risk in flooding and increased risk in wind risk. As I've mentioned earlier, there has been an increase in intensity of tropical cyclones, and because of the increased wind, we are expecting to have a more severe storm surge in the future. So as Philippines, why are we very vulnerable to water-related hazards? So firstly, the position of the Philippines, we are located in the Pacific Ring of Fire, or in the immediately on the side of Northwestern Pacific. So Northwestern Pacific Basin is the largest basin ocean basin all over the world. So the larger surface area tends to absorb more solar energy from the sun, in return produces more evaporation, and this evaporation have a lot of water vapor in the atmosphere, which in turn is being generated as a tropical cyclone depending on the pressure area on different locations. So just a trivia, do you know that the country that has most experienced landfalling tropical cyclones on the globe is China? However, because of their surface area, they tend to receive a lot of tropical cyclones, but Philippines is the second country who experienced landfalling tropical cyclones because we are directly in front of the Pacific. The third one is Japan. So as you can see on this figure, we tend to catch all the tropical cyclones passing towards Asia. So that's why we are very vulnerable to tropical cyclones and its risk. The second one, deforestation, is the because of the lack of trees in the mountainous areas. When even a normal amount of rainfall is received, there is not enough values on the soil that will absorb this water, so it tends to flow towards the low-lying elevation areas. So instead of being absorbed and being used by the trees, the excess water is being sent out to the low-lying areas. The third one is poverty, of course. Because of the restrictions in fundings, we have limitations in researches, in infrastructures, in mitigation strategies that would help us mitigate this kind of disasters. So because of the poverty, we have the poor urban development. So a lot of people tend to live on the dangerous areas because it's cheap. And such, but they didn't know that these areas are very vulnerable to rainfall-related hazards. And because of the limitations in funding, we also have limited research capability, which really would help the community in order to prepare for these kinds of disasters in the future. For the Philippines, under the national government, the agencies that are responsible for mitigating disasters on different kind of senses would be the Department of Science and Technology, Department of Interior and Local Government, and there's the DSWD and NDRRMC, and lastly, the individual local government units. So under Department of Science and Technology, we have different institutes that is focused on disaster mitigation. So a couple of them are the Pag-asa, PHIVOX, and Project NOAA. So PAGASA is the Philippine Atmospheric Geophysical Astronomical Services Administration, is the agency responsible for monitoring, forecasting tropical cyclone and its water-related hazards to the Philippines. So you have different regional agencies all over the Philippines. So mostly the data related to Philippine weather can be gathered from PAGASA. The NOAA Center, or the Nationwide Operational Assessment of Hazards, is responsible for making hazard maps for the whole Philippines. So included in these maps are the flood hazard maps. There's the rainfall-induced landslides, and storm surge hazard maps for the whole country. And then, what is tropical cyclone in the Philippines? So for global information, the tropical cyclones, hurricanes are being measured through the Saffir-Simpson hurricane scale. So this hurricane scale is categorized into 5 categories depending on the strength and the pressure and how much wind it can produce and how much distraction it can produce. So if we can agree that category 5 typhoon are the most dangerous typhoons, they are more than 250 kilometers per hour wind speed tropical cyclones, and this kinds of winds are capable of destroying many buildings and cutting off major roads and such. So for the Philippines, in recent memory, some of the most disastrous typhoons in the Philippines would be Typhoon Sendong in 2011, which had produced a lot of flooding and debris flow in that area. We have the Typhoon Ondoy in 2009, which is very well known to people living in Metro Manila because this is an unexpected event. It's a 24-hour rainfall event that had produced a lot of increased overflow and pluvial flooding in the city. And then lastly, we have the Typhoon Yolanda of 2013, which had unfortunately resulted to about more than 6,000 casualties in the eastern side of the Philippines in 2013, which is mostly resulted from the storm surge resulting from the typhoon. So for Metro Manila, for a more localized information, what are the extreme rainfall events in Metro Manila in recent memory? So Metro Manila is located in the Marikina-Pasig River Basin. So this basin have a mountainous regions of Rizal, Montalban, Antipolo on the eastern side, and the water flowing the mountainous area flows towards the river outside Manila Bay or Laguna de Bay. So since 30 years ago, most of the extreme rainfall events in Metro Manila would be Typhoon Ondoy of 2009. We have the Habagat 2012. We have Habagat 2013. We have Typhoon 2018. And we have the Typhoon Ulysses in 2020. So as you can see in the figure, this is a comparison of the developing countries in the world and the locations that are vulnerable to climate change. So as you can see on the left side, the developed countries such as the North America, European countries, Japan, Korea, Australia are all developed countries. And the orange ones, including the Philippines, is categorized as developing countries. So meaning that we have limited resources to be able to produce researches or disaster mitigation strategies regarding these events. So that's the reason why we are one of the most vulnerable countries in the world relating to climate change hazards. So as you can see at the bottom, for Asia Pacific countries, we are the most vulnerable in natural hazards overall, and single hazards would be we are on the 7th place, but still Philippines is one of the most vulnerable countries related to climate change hazards. So why are developing countries vulnerable to climate change hazards? One of the reason is that there is an high challenge in obtaining data for research. The reasons for this is that because of funding constraints, we have limited infrastructure, we have limitations in trainings and expertise, there's data collection gaps, so there's inconsistency in data standards, and due to the remote environment, it's very hard to provide measuring instruments regarding this. So those are some of the reasons why it's very hard to obtain hydrometeorological data in developing countries. So as a student research, how can we solve this issue? So why, where, and how can we get this data? So based on my experience, I have been doing research for 10 years. We need to find different solutions and how to overcome the limitations in obtaining of data for developing countries such as our country. So for hydrometeorological hazard research, it's divided into 3 categories. We have the meteorological data, which includes rainfall, tropical cyclone intensity, tracks, weather charts, remote sensing data, and numerical weather data. So we're also curious in knowing about the climatological data. So this pertains to the El Nino and La Nina oscillation. So we wanted to know, is the recent event related to the La Nina oscillation? Is it a normal pattern, or is it a climate-induced extreme event? So we also have different kinds of global oscillations that can trigger the extreme rainfall. We have the Madden-Julian oscillation and the quasi-biennial oscillation. For hydrological data, it is important for us to get the elevation data of the surface we are trying to study. We also need to know the infiltration capability of the soil. We need to know the surface roughness, or how is the properties of the soil can impede the flow of flood, which in turn can reduce the hazard. And lastly, we wanted to know the water level on rivers and how high or how low is being affected by the rainfall event. So for meteorological data, rainfall, of course, is being provided by the PAGASA. So you can get the rainfall data, spatial and temporal, to the Meteorological Agency of the Philippines. However, if you need time series data, you can download the information from the DOST ASTI, or the Advanced Science and Technology Institute. Or if they are not available, you can download the information to NOAA, or the National Oceanic and Atmospheric Administration. So as you can see in this image, for example, in Science Garden, Quezon City, 3-hourly data is available for temperature, dew point temperature, maximum minimum temperature. We have the wind direction, we have the surface pressure, and then we have the precipitation and such. So this information, if you are interested in plotting the increase and decrease in precipitation for a long time or a short period of time, you can get the information in these websites. Next, typhoon information, of course, is being provided by PAGASA. However, if you wanted to have a comparison of the data, forecast data, or the archive data, you can also download the information from Japan Meteorological Agency, or JMA. They also monitor the northwestern Pacific. So the typhoon information they release is also the same typhoon information Pagasa is being released. And then we also have the Joint Typhoon Warning Center. This center, or JTWC, is the center responsible for forecasting tropical cyclones in the northwestern Pacific. So Pag-asa is only responsible for the typhoons entering the Philippine area of responsibility, but these two agencies, they do forecasting and monitoring for all the typhoons within the northwestern Pacific. Next is weather charts. Weather charts are used to identify the locations of low pressure areas and the direction of wind speed. So if you can see on the weather charts, the circular areas are the tropical cyclones. The more circular it is, the more intense it is. The faster the maximum wind speed. So you can get this information from Pagasa. So they provide you can view the manual plotting. In addition, you can also see the global spectral model output, which is plots the sea level pressure and 3-hourly rainfall and surface wind. However, if you're interested on looking out on the bigger picture, you can get information from the Bureau of Meteorology side BOM Australia, and you can also get information from the Thailand Meteorological Agency, or TMD. So some of the weather charts you can also download from NOGAPS. This is the US Navy weather monitoring administration, and you can also view the information from Windy and Earth. So for like amateur meteorologists, or if you're interested, you can have these apps or websites to see if you wanted to monitor the activities of tropical cyclones coming into the Philippine area of responsibility. So these are not restricted to researchers. All public can view this. So with this information, you can derive what kind of strategies would you be doing in the next next couple of hours. So being well educated would help a lot in disaster mitigation. So we have the satellite images, which is also provided by Pagasa, the Doppler radar, which monitors the precipitation capability of the clouds, is being provided by them. However, if you need archive data, this information is also available from JMA, from Japan Meteorological Agency. The upper right one, the lower right one is from NOAA GOES, and then the global satellite image can also be downloaded from NEODAS, from United Kingdom, and from KMA, or Korea Meteorological Administration. So these information, because satellite information is global, so even though you are only interested on the data for the Philippines, you can check on global data and assess the situation from there. We have the reanalysis data you can get from National Centers for Environmental Prediction and National Centers for Atmospheric Research. For climatological data, if you're interested in identifying the status of El Nino and La Nina events, you can download the information from National Centers for Environmental Information. So as you can see in this graph, the upper data shows the El Nino timelines, and then the lower graph you can see the La Nina timelines. So if you can see, like, if there is an extreme event recently, you check the website if it's La Nina or El Nino or La Nina season, then you can see that, oh, this is caused by La Nina and such. So MJO can be downloaded from Bureau of Meteorology Australia and NOAA USA. And then quasi-biennial oscillation can be accessed to NASA, and NCEP-NCAR. For hydrological data, so not all rainfall results to flooding. So a part of this rainfall is being evaporated back into the atmosphere. Some of them is being, we call it evapotranspiration. So the plants absorb the water and release back into the atmosphere. We have the infiltration. So a portion of the water is being absorbed for groundwater storage. And we have the water storage by rivers. So all excess water coming from the rainfall can result to flooding. If there's a lot of excess water, then it's going to result to flooding. So the remote sensing data, if you want to see the land use change, can be accessed to United States Geological Survey. So you can see the difference from timelines. This is important in urban flooding. GIS data can be gathered to fill LiDAR dream, and shape files for administrative boundaries, country boundaries can be downloaded to Humanitarian Data Exchange and IGIS map. Water level data. This is very important because we wanted to monitor if there is an increase of water level related to the intensive rainfall. So those information can be gathered from the Pagasa website. So you can see the critical elevation here, or if it's not available, then you can download it to the field sensors of ASTI. So you can see the change in water level over time to different stream gauge stations in the country. And soil type, which is important in infiltration, you can get to Geoportal Philippines, as well as surface roughness, which is land use classification. This is also downloadable to the Geoportal Philippines. So using this information, what can we do? So you can do event researches. So you wanted to know the reason why the driving mechanisms between these rainfall events. So in 2012, we can see we have extreme flooding in Metro Manila in 2012. So investigating the result, we have found out that the reason for the stagnation of the air mass is because there's two tropical cyclones outside the Philippine area of responsibility, which instigated to the impedance of the air mass, which resulted to a lot of rainfall in one specific area. We can also do hazard mapping for storm surge using the information for typhoon location, intensity, and central pressure. Or we can do flood simulation for if we have this information, such as the Typhoon Ondoy 2009 flooding or the Typhoon 2020 urban flooding. So as students, as researchers, I encourage everyone to be curious, to gather all your researches to know as much as you can. Being curious makes you informed, makes you study, and makes you know a lot of information regarding these events. Take actions in different forms, helping your community or conducting researches for the improvement of the community, and look after one another. And most importantly, as the society of younger people, be part of the future problem solvers. And I think that's the end of my presentation. Thank you very much for listening.
Thank you very much, Dr. Leah, for that very interesting and informative presentation. Being a forester as well and being exposed to this kind of information, I still learned a lot about meteorology and about the hazards caused by tropical cyclones and climate change. And I'm sure as well that our audience has learned a lot as well. I hope what we can pick up as well from Dr. Leah's presentation is that we have plenty of information and data available to us. right now with the technology and internet, it's very easy to access this information. And for the young researchers and aspiring researchers we have in this audience, I hope we can utilize um this data, this rich source of data to create innovations to help our community. As Dr. Leah said, as we must be curious, we must be informed, we must take actions and look after each other for to be future problem solvers. So we can practice that right now, being curious. In our next session, the Q&A session. A few reminders for our audience. We kindly use the Zoom reaction button to raise your hand and wait for the host, me, to call your name and unmute you before speaking. We also entertain questions sent to the chat box below. Same with our audience from FB Live and YouTube. You may also comment your questions below. So now I open the floor for our question and answer session. You can send your questions below in the chat box or raise your hand and I will call out your name so you can unmute you. So you can unmute yourself. Oh, we have our few questions from Miss Raisa, one of our audience here at Zoom. She asked, Miss Raisa works at the UPNC PAG. I just have one question. Based on your experience, what critical measures do other counties that are equally hazard prone and are situated in the Pacific Ring of Fire employ to become more hazard resilient that the Philippines does?
The other countries do that Philippines don't have.
Mm-hmm.
It mostly triggered down to availability of resources, of course. If we have a lot of resources, it is easy to take preparatory actions instead of reactive actions. So, for example, here in Korea, I'm working at the hazard water hazard assessment research institute. So for this agency, instead of like preparing for instead of like making reactive reactions from extreme rainfall event, they do researches intensive climate related researches that allows them to prepare for future hazards, which is I think is very necessary if we wanted to prepare for the next 10, 50, or 100 years. So for them, they have the necessary capability to install a lot of monitoring stations. So for example, in Metro Manila, we only have 4 working rainfall stations in the whole watershed. According to WMO standards, we need to have at least 1 rainfall station within 20 kilometers squared. So for this, we should be having 50 stations within the watershed, but we only have 4, which is very limiting to kind of researches or preparatory strategies we wanted to in the future. So I think yes, that's one.
Thank you. As Doc Leah said, prevention is better than cure. So as young researchers, what we can do as well is influence others, inform other people, especially the policymakers of our government, to take actions towards climate resiliency and being prepared towards other hazards. Thank you, Dr. Leah, and thank you to our audience for their question. We are still accepting questions, so ask away, everyone. Oh, hello, doc. Hello, doc. You can now unmute and ask your question to sir.
Ako ba yon?
Yes,
Am I the
sir.
one? Hi,
That's
Leia.
right.
Sir,
How
kumusta?
Musta? Oh. How do the Koreans model climate change projections? For example, in the IPCC reports, they say that the rains will become more intense. How do they model in Korea future rainfall due to climate change?
In Korea, andun po yung APEC Climate Center, yung for parang climate change mitigating strategies for Asia Pacific countries. So, merong different models ng RCP projection sa buong mundo. Siguro mga 100 models. So, ang ginagawa ng center is kinukuha niya yung lahat ng data from different models ng climate projections ng RCP and then fino-forecast niya.
Okay.
Yes,
Now,
sir.
okay. Now, with that rainfall, what do they do next? Because the rain does not kill, di ba?
It's the flood that kills,
The
yes.
flood that kills. So, what do they do next? How do they model the floods?
Yung pinaka flood forecasting agency ng Korea, which is K-Water, nag-develop sila ng hydrological model tsaka hydraulic model to simulate yung flood distribution depending sa elevation. So same ng Flow 2D, same nung ginamit po natin sa Project NOAA. However, they developed their own based on the regional characteristics ng kanilang watershed. Dahil mas high resolution yung kanilang surface elevation, siguro mga 1 meter po. They do small scale flooding and using the rainfall projections from climate change. So they do that too.
Okay. So, this is also what they're doing. Parang, kasi
Opo.
we're doing it now. We've been doing that, at
Yes.
in the university. And now, we are including the drainage as well.
Opo.
Do they do that in Korea?
Sa malalaking cities po, example, Seoul and Busan, meron silang integrated sewer flood modeling na kasama po yung information ng laki ng pipe, ng dami ng storm drainage. Pero dahil data intensive niya, hindi niya kayang mag-simulate ng malaking watershed. So mostly dun sa pinaka-populous area, nagsasimulate sila ng inundation plus sewer pipe system ng flooding. Pero ang difference po kasi sa kanila, ang rainfall sa atin at ang rainfall sa Korea ay napakalaking difference. Yung konting rainfall sa kanila, konting baha na po sa kanila yon. Pero sa atin, kapag hanggang bewang, pwede pang pumasok. So, they're preparing for even though it's a very small effect, they're preparing for the worst. So, that's one of the advantages of having a lot of resources, I think.
Okay. When you're in the Philippines, please visit UPRI and the NOAA Center.
Sige po.
Because, I need you to look at the integrated drainage and surface flood models that the researchers are doing.
Yes, sir. Meron po tayong data ng sewer pipe sa
Hindi
Manila.
kompleto, pero the best yung magkakaroon ng magandang inventory.
Yes, sir. Opo.
But sa Quezon City, we're doing that. It's incomplete, but we had to do with what we have.
Yes, sir. Okay po.
Yeah. When you're in the Philippines, please visit us.
Sige po. I will keep you. Okay.
Sige. Okay.
Yes, ma'am. I hope makavisit pa yun sa amin and to meet you in person.
Okay.
And I hope yung mga natutunan nyo po dyan sa Korea is may apply din po natin dito sa Philippines. Yun. May mga nai-inspire po kayong mga young researchers here in our audience. As one of our participants asked, what is your motivation for pursuing research studies in water-based disasters?
Ay, Miss Universe. Ang nag-inspire po sa akin ay Typhoon Rosing of 1998. During that time, taga Antipolo po ako. So, ang lakas ng bagyo and we had a lot of parang hazard, delikado ng panahon. And that time, I was interested in anything related to atmospheric dynamics. So that's the reason why I pursued meteorology. Dahil interested ako sa atmosphere. And then when I worked for Project NOAA, that is I realized the effect of the changes in atmosphere, yung resulting niya kung gaano siya makaka-epekto sa tao as a community. So that is the reason why I studied flooding in as for my PhD degree. So those information as curiosity and the willingness to help people be part of the solution during that time is my those are my motivations to study researches like this.
Mhm. Thank you, ma'am. Yun napakita din naman ni Doc Leia kanina yung mga agencies related to disaster preparedness, and I hope for our young audience here, the students, the aspiring researchers, you can join us in this industry and help us combat climate change.
Yes,
Be climate warriors, guys. Climate warriors.
exactly.
So we have, ma'am, another question from
Mhm.
Miss Louise Perry. Based on your experience and knowledge, how can the LGU be exposed to this kind of information, especially in taking advantage of these resources to enhance their disaster risk management plans?
I think UPRI has been doing this for a long time. Since NOAA time, we have been doing like disaster mitigation seminars and workshops to disaster-prone areas. For example, for storm surge-prone areas, pumunta po kami sa mga lugar na yan and to give them information on ano yung mga safe na lugar. And surprisingly, they are very curious because it's their community that's being affected. So the small local government units, not just the mayor and municipal level units, we need to focus on the district level or the barangay level because they know their neighborhood. So kapag may disaster na ganitong mangyayari, sino ba yung unang tutulong sa'yo kundi yung kapitbahay mo, di ba? So knowing your risk, what kind of risk you have on your community is very important. Even watching news, telling people na, oh, may paparating na bagyo, then ano yung, saan papunta, so ano yung strategies natin. So those are the informations that's necessary for helping each other for disaster events like this.
Thank you, Doc. Luis, I hope Dr. Leah was able to answer your question. So we have our next question from our audience here on Zoom again. Aside from the lack of available data, what are the challenges you have encountered as a young career scientist in doing research?
Aside from the data, it's mostly the saan ka kukuha ng educational, paano mo malalaman, paano mo aaralin. Gusto mong matuto ng programming, paano mo aaralin? Gusto mong matuto ng climate change, ano yung mga seminars na pwede mong attendan. So if you are just straightforward student, you just wanted to learn what your teachers are teaching you. But if you really wanted to learn more and expand your knowledge, you have to find other means to get this information. So andyan yung manood ka ng seminars from good universities or good professors. Andyan yung umattend ka ng different conferences para makausap mo yung iba't ibang researchers from different countries. If you are really interested and you really wanted to learn as much as you can, you need to find another mean of getting information, not just what you are presented, but you have to think outside of the box, such as these information. So susuko ka na ba agad? Hindi ko, wala silang rainfall data, wala silang water level data. Susuko ka na agad. You have to find another alternative solution to be able to provide solution for this kind of situation. So that's what I advise to prospective researchers or students be resourceful and think outside of the box as much as possible.
Yes. And dahil na rin sa technology we have right now, access to this kind of information, seminar, symposium, or any collaborative
Exactly.
meetings
Yeah.
with other scientists are actually very available, and most of them are free. And having said that, actually the UP Resilience Institute will be conducting basic resilience online courses. So guys, join us. And ito, yung Resilience Live, this is our way of influencing students, young researchers, or people from other sectors. Kasi, yun nga, climate resilience does not, hindi lang siya limited sa environmental impacts. It impacts the overall well-being ng community natin, but especially yung health ng mga tao. So, tulong-tulong tayo sa combat ng climate change to help everyone in our community. Ayun. So, thank you all very much for our audience for actively participating in today's episode. We have received more questions actually, but due to limited time, we need to close the question and answer session already. To those who were unable to ask their questions, you may send them to our UPRI Facebook page, and we assure that we will be forwarding them to Dr. Leah. Thank you once again, Doc Leia, for sharing your knowledge on tropical cyclones and water-related disasters and climate change and information to our young researchers. Before we officially end this episode, we would just like to request everyone to open your videos for a quick photo op, everyone. Open your videos. Okay. Page 1, smile. Okay, page 2. Smile. Ayan. Ang dami naman po ng researchers natin, mga interested audience.
Pero nahihiya, puro pictures.
Okay. Thank you, everyone. Thank you po. So, at this point in time, we now move on to the end of our webinar. Again, this webinar has been brought to you by the UP NOAA Center and the UP Resilience Institute in partnership with the UNESCO International Geoscience Program. We would also like to thank again our partners for this episode, the UP Phi Delta Alpha Sorority, the UP Society of Geodetic Engineering Majors or UPGEOP, the Association of Filipino Forestry Students UPLB, and the Lyceum of the Philippines Laguna Biological Society. Our next episode will be on the 25th of January next year. So stay tuned at the UPRI Facebook page for announcement on our next speaker and featured topic. To our audience, please be reminded that we will be issuing a certificate of attendance once you have completed the evaluation form after the webinar. You may find the link to the form in the chat box below. And to our webinar participants, we will keep the Zoom meeting to allow participants to fill up the evaluation form. Again, thank you everyone. Thank you everyone, and see you all at the next session of the Resilience Live. Once again, my name is Ella, and it has been a pleasure being your host for this afternoon. Thank you. Bye-bye.
Thank you. Thank you.
Thank you, everyone.
Thank you.
To all participants, please be advised that we will be closing the webinar in 5 minutes. Please make sure you have filled out the evaluation form. Thank you.